We often hear about the IT and OT divide, meaning IT being information technology, OT being operations technology. The operations people have real-time operations that they're trying to keep running. They're worried about efficiency, equipment failures, and so they need their systems like the PI system to be able to keep those systems running. In the information technology space, we're often looking at platforms that can go across the whole business, the whole enterprise. So we have the OT people that need to get their job done. They want their operations tools. We have the IT people who want to save money and build out common platforms. And so our focus within OSIsoft has been to take the PI system and make sure it's available for those OT people, but to bridge the gap between IT and OT tools. So being able to take your operations data and have it be used with the proper context in the environment that your IT group wants to move forward. And that might be big data analytics tools, it might be more traditional enterprise data warehouses or business intelligence tools or others. But the combination of systems is really powerful. Use the right tool for the job and you create better things that way. So with big data tools, it's often the business owners that really want the results, and the team they put together typically is a combination of IT that can bring data together from multiple systems, mathematicians and statistics gurus who understand the big data tools that can be used to process the data, and then the subject matter experts, the people who understand what the data really means. So you need to kind of have all three. Often our PI users end up being those subject matter experts because they can offer the context of how to interpret it towards something that's meaningful. So a lot of the techniques used in big data analytics for consumer applications are applicable in terms of the techniques used in operations data. So a good example of that is fraud detection. So you teach a model. These are the different patterns that indicate there could be something fraudulent going on. And then there's real-time streaming analysis being done to watch over credit card transactions to look for those patterns. So that same kind of processing can be used for, let's say, failure detection for why might a pump fail over time, or a particular type of pump. You need that historical data to train the model, and then you need the real-time scoring to look for, is that pattern being matched and is this pump moving towards failure, and then to drive some action.